going to this wall, and then coming off the wall. You know, I mean, it's like, I don't know. You know, and they were getting totally confused back here as to how to figure out that curve. So I'm going to show you guys what I showed them because it's a good little example of how you can use shadows. Now I'm going to do this mechanically, so that, or pseudo mechanically, so that you guys can really see it. I'm thinking there was something else. Now, if I can glance at the notes that Amy took and see if there's something else major about the cylinder particularly. Now, to draw this, I did not draw a cylinder to demonstrate, and there's a reason for this, because it has to do with how you want to think about the solution. If you put the cylinder there, it's going to get distracting. What I want you to do instead is, imagine I'm just going to make some random, some arbitrary lines. And what you're going to find is they are kind of in an arcing pattern. But they're not very, do you see that they kind of follow an elliptical pattern? But imagine there are 4 poles. Now in that, I'm going to draw it later in a different way, but imagine these weren't poles, but they represented like some kind of folding screen. You see what I mean? I'll draw it in darker later. But do you see that I'm going to cast this shadow onto the wall, and do you see that having those planes, when the shadow hits the wall, is going to get really weird. But let me show you how that would work, especially casting across the corner. Now, I'm going to put the light source like right here. So we cast these into the corner. All right. Oh, not yet. Oh no. It was totally confused.
No.
Yeah. My brain isn't functioning.
Oh, I got you.
I'm exhausted. I thought you were talking about the slopes. Yeah, okay, remind me about the sloping plane. So, you guys, here's what I want to show you. Imagine, oh shoot. Oh no. Alright, so do you see that, like, if I draw the shadow of this one, the normal way you would, okay, actually everyone keep your eyes up for a second. Okay, just watch me do this, because it's shadows. You guys know how it works. So like if I do the shadow of this one, the normal shadow would be here, just a tiny bit above the wall. So you draw that shadow, and then you would draw up. Okay, so that's the shadow of that one. The shadow of this one here, if you were drawing it without an awareness of the wall, it would land right here. Instead, we'd go to here and then draw a vertical until there. Okay, so we're good so far, right? Keep your eyes up. But now look what happens here. Imagine we've got these two, but then we get to this one. By the way, that's completely coincidental and unfortunate. So that one would be here. Instead, eyes up, don't take notes. That would be the shadow of that one. So do you see the problem is this? How do I get from here to here across that corner? That's a little evil because I'm not really dealing with vanishing points or anything like that. That's what makes it hard. If I had vanishing points, it'd be easy. But it's a little bit wicked as it stands. So this is the step. This is the whole point of this diagram. My concern is, where do they hit in the corner? So start at the corner and work backwards. Watch. If I connect the corner to the radiation line, I intersect this imaginary screen right there. I draw a vertical, imagining it actually exists, and I cast the shadow of that, and it hits right there in the corner. I've got a spot on the corner I can compare it to. Now I just need to go like this. And it totally looks undramatic because of where they landed. But do you see my point? That's what you do is you work backwards from the spot. Like if you have a change in surface like that, you find the point on the surface that you need to understand, and you figure out what part of the object is casting that shadow right there. And that gives you, it's kind of like doing this. It's like having a point here and having a point here, and you're thinking, well, shoot, I've got to go around this corner. You need to find that point to kind of be able to navigate like that. In the morning class, it turned out, well, so my point is this, bad pun. My point is this: you would find this point here on the shadow, and then maybe find a point here, and maybe find a point here. That's going to allow you to go, oh, it's doing that. You see what I mean? You have to do it point by point. Okay, so take any notes you need to on that. And I've got one additional thing to say about sloping. One of the other critiques I had was, and this is actually, it's a little challenging to explain this. There were 3 people in the morning class who have been really struggling mechanically. They were struggling from the very beginning, and they weren't, frankly, studying enough. And it was beating them up. And I told them so like a week or so ago, 2 weeks ago, I got on them a little bit and said, no, you guys need to take care of this. Kind of like what I did with you guys. You know, where I had the TAs mark the people who needed some extra work. Well, what was kind of nice was in the morning class, 3 of these people really have been working hard since then. And they've been studying very, very hard. And I can see the results in their work. Their work looks much, much, much better. It's still not good. They're still playing catch-up a little bit, but I can see they've made it tremendously forward. Okay? But this one guy in particular, actually there were 2 students who had this problem in a severe enough way where they're going to have to redo their mechanical. But what they had was the person had a cylinder. Imagine a scene like this.